bases and salts. How do acids and bases react with metals? So here we are going to understand how acids and bases react with metals. What's the reaction and what are the products formed? Let's move. We have this activity 2.3. We'll perform this activity virtually and understand acids and bases in a more deeper way. So let's move on. Set the apparatus as shown. So here in the apparatus we have a stand with a test tube on it. We have this delivery tube whose one end is in the test tube and the other end is in the soap solution. We are holding the candle and in the test tube we have dilute sulfuric acid along with zinc granules. Remember that we have put a cork over the test tube, and so whatever gas will be evolved through this test tube will directly go through the delivery tube. There is no way out for the gas to move anywhere else. So let's move on. Take about 5 ml of dilute sulfuric acid in the test tube and add few pieces of zinc granules to it. What do you observe on surface of zinc granules? So just list down what we have to observe. The first point is we have to observe the surface of zinc granules and pass the gas being evolved through the soap solution. So the gas which will be evolved will directly pass through the soap solution because there is a delivery tube does it. And why are the bubbles formed in the soap solution? So observation number 2 is that why are the bubbles formed in soap solution? Now take a burning candle near the gas filled bubble and note your observation. So we have to take a candle near the burning bubble, near the bubble and just observe what happens. Now answer will be the granulated zinc is added to dilute sulfuric acid. Hydrogen gas is evolved with effervescence. Since zinc is more reactive than hydrogen, it displaces it from its compound and forms zinc sulfate. A colorless, odorless gas is evolved with effervescence. So let's understand what actually happens here. When dilute sulfuric acid is reacts with zinc granules, we will see this hydrogen gas being evolved with effervescence. So this effervescence, what effervescence means? Effervescence means formation of small bubbles near the surface. And so point number 3 was what do you observe on the surface of zinc granules? We observe this small hydrogen bubbles. So first observation is met, and now the another observation is a colorless, odorless gas is evolved with effervescence. So along with effervescence, this colorless and odorless gas is being evolved. This gas is nothing but hydrogen. Okay. Now what will happen when this gas actually moves through the soap solution? Let's see. The zinc will react with sulfuric acid forming zinc sulfate dissolved in the solution and releasing hydrogen gas. So can you identify the type of reaction here? Which type of reaction it is? Zinc reacts with sulfuric acid and forms zinc sulfate and hydrogen. So let's see, the reaction is like this. The equation will be Zn plus H2SO4 forming ZnSO4 plus H2. This is a displacement reaction, and here hydrogen gas is released along with the effervescence. Okay. Now the bubbles formed in a soap solution is due to this hydrogen gas which is evolved from the reaction. When we take a burning candle near a gas filled with bubble, we hear a pop sound. This shows presence of hydrogen. So this is how hydrogen is being identified in many reactions. This is just a way to know whether hydrogen is present over any gas is hydrogen or not. So when we take this burning candle near the gas filled bubble, and we just hear the pop sound. This pop sound shows that the gas present is hydrogen. Now note that the metal in the above reaction displaces hydrogen atoms from the acids as hydrogen gas and forms a compound called salt. So by this you can see that ZnSO4 formed here is a salt because zinc basically displaces hydrogen from H2SO4 and forms its own compound named ZnSO4, and H2 is just released out, right? So you can say that ZnSO4 is a salt here. Now thus, the reaction of the metal with an acid can be summarized as acid plus metal forming salt plus hydrogen gas. So you just can correlate both the reactions written in blue. It is here acid is H2SO4, metal is zinc which is Zn, salt form is ZnSO4, and hydrogen gas is mandatory in this reaction. So this was activity 2.3. Now next activity 2.4. Place a few pieces of granulated zinc metal in a test tube. We have to take few pieces of granulated zinc metal in a test tube and add 2 ml of sodium hydroxide solution and warm the contents of the test tube. So we'll just take sodium hydroxide. Sodium hydroxide is NaOH, and we'll just add it to the test tube in which we had added granulated zinc and warm the contents of this test tube. Now repeat this rest of the steps as in activity 2.3 and record the observation. So we have to record the observation just like we did for activity 2.3. Remember, we use this delivery tube for bubble and forming bubbles near the soap solution, right? Now answer here will be, when sodium hydroxide is added to granulated zinc and heated, hydrogen gas is evolved with effervescence. So again here we observe hydrogen gas being evolved along with effervescence, and so bubbles are being seen near the surface of zinc granules. Since zinc is more reactive than hydrogen, it displaces from its compound and forms sodium zincate. Now the reaction for this, or the equation for this reaction is as follows: NaOH plus Zn forming Na2ZnO2 plus H2. This is an important reaction, so memorize it quite efficiently. NaOH plus Zn forming Na2ZnO2 plus H2. This compound Na2ZnO2 is sodium zincate. Okay. Now, however, such reactions are not possible with all metals. This is an important point to note. There are some metals which won't react with NaOH. Some will react in a different way with NaOH. So you just can't determine that every metal reacting with NaOH will form some kind of salt and hydrogen gas. Okay. So